depending on the size of your sequence, of course, it's easy to add a handful of numbers in the home screen calculator. If you have a very large sequence, they want you to add them up. There is a formula, and I'm going to give you the formula sheet today, which remember, you will get that on every quiz test, the final exam, all the things. Okay, so let's just jot this down because I'm going to use this one. This is from yesterday. So what is the nth formula for an arithmetic sequence? So this is what we used all day yesterday. So it's that first term, n minus 1, common difference. You don't have to have it memorized. It's on the sheet, but we're going to use it today. So this is just a practice or review what we did yesterday. Find the nth formula for the arithmetic sequence. So I'm going to use that formula again today. So first term is 7, n minus 1. Okay, you do a little bit of mental math there quick for me. What's happening between the terms of the sequence? What's your common difference? 2. Up or down? Down. So I'm going to put -2 for the difference. Remember, we're just going to distribute because there'll be some like terms that we can combine in here and make it look good. So I'm going to have -2n and +2. And let's add 7 and 2 together. And remember, we like to generate the formula because then, you know, if I want to ask you something crazy like what's the 500th term in the sequence, you can just easily in your calculator put 500 in for n and calculate it, okay? But keep this formula, like I said, it is on the formula sheet, this red one. You don't have to have it memorized, but I am going to use it in a couple of the problems today, just for the record. All right, let's get into the sums here. So first 2 terms of the sequence are given, find the missing term, and then of course we're going to practice some of this and get into the sums. So first things first, whenever you're doing these arithmetic, you need that difference. Well, this one's pretty easy to do. The first term's 3, second term is 13. What's your common difference? 10. Just some quick, easy mental math. Now I'm going to use my formula, of course. So my first term, 3, that n minus 1 times our common difference. I'm going to distribute, make it look good. You know the drill. So 10 times n, 10 times -1. Let's combine the 3 and -10. So I'm going to have 10n minus 7. So nothing new, nothing crazy there. And now, of course, they want final answer, the 9th term. So let's just put a 9 in for n. So we're going to do 10 times 9 minus 7. What's 10 times 9 minus 7? 83. Got it. So just a little review from yesterday. If you need a specific term, nothing too wild or crazy. So we're going to do one more like this, but of course, you know, I jazzed it up and threw some decimals in here. Ooh, crazy. I don't know. Okay, let's first get the difference. So from -0.7 to -13.7. Probably want your calculator for this, no judgment. How much are you going down by? 13.1. 13.1. Good, mental math. I like it. Of course, you can subtract them in your calculator if you're not great with decimals, you know. No judgment, maybe a little judgment. Okay, let's write out our formula. First term is that -0.7, n minus 1, common difference. You know the drill. We're going to distribute, combine the like terms, all the things. So -13.1 times n. Should have just made that a minus, I guess. And then plus 13.1. All right, I always like the variable first, so I'm going to put the -13.1n first. What's -0.7 plus 13.1? Might need your calculator for that. Got it. Okay. Now, easy enough. They want you to come up for a final answer with your 8th term. So let's just put an 8 in there for the n. And again, you might want your calculator for this. So times 8. I'll give you a sec to punch that in. Kind of a big answer. Yep, got it. So a little quick review of kind of some of the things that we did yesterday. Nothing too crazy or wild on that. Any questions on that? All right, you guys are up. You try this one. So there's your first term, your second term. I want the 7th term. Probably want your calculator because of the decimals. All right, so final answer, of course, -10.2. Anybody need any of the work for it? Okay, so I've got some hands for the work, so let's do it. So difference, of course, we already figured that out. From 4.2 to 1.8, we said you're going down by how much? Got it. So then I'm going to do my formula, the first term, 4.2, plus n minus 1, that's a plus, times that common difference. This board is driving me nuts. All right, let's distribute and combine our like terms. So 4.2, I'm going to have negative 2.4n, and then plus 2.4. You know I like the variable first. You don't have to put the variable term first. I just like it that way. 4.2, 2.4 added up 6.6. Then all you have to do to get the seventh term is put a 7 in there and punch it in your calculator, and that will get it. Okay. Because you said you didn't have the 0.2, Derek, so I'm guessing you just accidentally typed something wrong.
Yeah, you put it at 6.8. It looks like
Oh.
you put it at 6.8.
Little things, little things. Okay, so this is review. We have, I've been kind of putting some review stuff in here from before spring break because, it's easy to forget stuff. This is review. Use the table feature of your graphing calculator to do the first 10 terms. Assume n begins with 1. Now, could you put 1 in for n, 2 in for n, 3 in for n, 4, all the way to 10? Sure, yeah, sure. That seems like a lot of work. Who wants to do that? So simple and easy. Pull up your calculator. I'm not even going to get crazy and switch it into sequence mode or anything. I'm just going to go with it as it is. I'm going to go into y equals. I'm going to clear this out, clearly, obviously. And I'm going to type in our expression, 17 plus 3. And who cares what the variable is? Instead of n, I'm just going to keep it as x. That's fine. Now, it says to use the table feature. I'm not going to hit graph. Of course, that would make a line if we graph it. But I want the table, so second graph. And remember, it says you're starting with 1. Okay, so my first term is 20, second term 23, third term 26, fourth term 29. So I'm going to steal this table here. Maybe. Come on, calculator. I'm going to try to steal it. I'm going to try to steal it. Anyway, maybe. Let's just write down these first 10 terms. Technology. I need you to put that on the screen. Well, write down your first 10 terms. It's not letting me steal it. And again, you could do it by hand. Honestly, I don't think it's bad to do by hand because what's the pattern? They're going up by what? 3. I think you can add 3 pretty quickly. But that's how you can always check it, of course, in your calculator. Okay. So really, the whole front page of your notes is just review stuff. Some things from yesterday. This is from before spring break. Now we're going to get into the sum of these arithmetic sequences. Okay, so flip it over, flip the page here. So the sum of a finite arithmetic sequence. Now finite, remember that just means a limited amount of terms, not the entire infinite sequence. Maybe we want the sum of the first 20 terms is all. So of course, it's given by this very lovely formula. Now this is on your formula sheet, okay? So just to explain what all this crazy notation means, clearly S is for the sum. N is the number of terms you're doing the sum of. So if I ask you for the sum of the first 50 terms, 50 over 2. A1 is the first term. We always know that. AN is the last term. So if I'm asking you to get me the sum of the first 50 terms, that would be whatever that 50th term is. Now that's where it gets a little dicey. They might give that to you. We might have to actually find it and calculate it like we were doing earlier today and yesterday with the first formula. Just kind of depends, okay? All right, just some vocab here at the bottom. The sum of the first n terms of an infinite sequence, they call it the nth partial sum. We've seen the words partial sum before. That just means obviously you're not doing the entire infinite sequence. You're doing a limited amount of terms. All right, let's get to it. So find the sum of the first. Okay, now here's the thing. Could you just probably add those relatively quickly in the home screen on your calculator? Yeah, I probably could. But they want me to use the formula, okay? So they might specify to use the formula. We have to know how to use the formula. So I'm just going to do a quick count. I have 1, 2, 3, 4, 5, 6, 7 terms. So I'm going to get fancy, the sum of the first 7 terms. Okay, formula. So it's number of terms over 2. Take a little look up there. Your first term, of course, 1. Last term, 19. So really, I think I can do this without a calculator because 1 plus 19, 20. So I'm going to have 140 over 2. What's 140 over 2? 70. Now, is that any quicker than if I just add them up? I don't know, I really can't tell you that, okay? But of course, if I ask like for a lot of terms, I for sure want to use the formula on it. That you could just straight add. But of course, like on your quiz, it might tell you, make sure to use the formula. So you have to be able to set that up at least correctly, and then I guess how you type it into your calculator is really your call. I'm gonna use the formula. I'm gonna do a quick count, 1, 2, 3, 4, 5, 6 terms this time, so we're doing the sum of the first 6 terms. And of course your formula, it's the first term, -2, plus our last term, -17. All right, I'll let you punch that in however you want. Let's get a final answer. -57, got it. All right, let's look at this guy. Ooh, sum of the first 50 positive even integers. I don't know about you, but I'm not writing out 50 positive even integers and then adding them to my calculator. We're definitely going to use our formula for this one. So 50 of them. So 50 over 2. Okay, so let's think about this. Positive even integer. Integer, of course, just means a whole number, no decimals, fractions, etc. So first question for you, what's the first positive even integer? 2. Sometimes I have kids that say, what about 0? Well, we gotta talk number theory. Is 0 even?
No.
It's neither even nor odd. It's considered neutral, just for the record. Okay, what would be your 50th positive even integer? 100. 50 times 2. All right, punch that in the calculator. Let's get this up. Got it. Piece of cake. Okay. So that one for sure, the formula is beneficial. I don't want to write out 50 numbers and add them. Who's got time for that? All right, find the indicated nth partial sum. Okay, all right. 25 terms. Now, they've only given us 1, 2, 3, 4 terms up there. I do not want to write out 25 and then add them. So I'm going to use my formula, of course, okay? So 25 terms. 25 over 2. Okay, first term 2. We got a little glitch here. Do you know what the 25th term is? No. So I'm going to have to find it. So here I'm going to use yesterday's formula like we were doing earlier in the day. So my first term 2, n minus 1. Do a little quick mental math here. What's the common difference between these? It's going up by 6. So now I'm back to yesterday, so this is kind of a combo of formulas, because I need to get the 25th term here. I'm not writing them out. 6 times n, 6 times -1. And of course I'm going to combine the 2 and the -6 together. Now the reason I did all of that is now I can put a 25 in there and get the 25th term. So what's 6 times 25 minus 4? Got it. So now I'm going to go back up to my sum formula and finish it and put the 146 in there. So what's your final answer? Something there, go.
1,800.
Perfect. So this is the only thing that might get just a little dicey on you today, is they don't give you the last term, so you have to use yesterday's formula. Not that it's hard, but it is a little tedious to go through and do the work, and then put your 25 in to get the last one. All right, let's see what our next one, what do we got? Okay, first term 15, 100, 307. I think we're in business on this one. So they want us to do the sum of the first 100 terms. I'm not going to write 100 numbers and add them. Let's get serious. Okay, do you know the first term? Yeah, 15, right? Do you know the 100th term? Yeah, winning. You just got to punch it in. Big answer.
16,000.
Perfect. All right, any questions on that formula? Okay, final three. So we're gonna do a couple still with the formula. So find that partial sum without using a graphing utility. Now, let's explain that. Because of course, I might need my calculator like to do this. I don't expect you to mental math, that sort of stuff. But when it says without a calculator, that means you're not just hitting math 0. We're gonna practice that again. Remember, math 0 pulls up the sigma notation and you can just punch that in and it'll spit the answer out. We're still using the formula like previous. Remember, this very lovely sigma means you're doing the sum. They want you to add the terms. Well, from 1 to 50, I mean, that's 50 terms. I'm not adding 50 numbers up. We're going to use the same formula I have been using. So we're doing 1 to 50, 50 terms. Now, I do need the first term. Some of you, of course, can just do some quick mental math and don't even have to write anything. I'm just going to write it. I'm going to put a 1 in for n like we've been doing since day 1. All right, 2 plus 1, 3. Yeah. You need the 50th term. That's an A, a sloppy A. So I'm going to do 2 times 50 plus 1. Okay, 2 times 50, 100 plus 1. Got it. And then, of course, I'm going to type that. Really, I do 25 times 104 in my calculator. But let's punch that in and get our final answer. $2,600. And again, I probably have way more work here than the first and the last term. You can mental math it, that's fine. Okay, same thing. I'm not doing 100 terms. I'm not writing 100 terms out and adding them. We're going to use our formula. 1 to 100, 100. And remember, this sometimes they display the lower limit, upper limit, the 1 and the 100 next to the sigma, just a different way to display it. So I just, covering all the bases. 100 over 2. Now again, some of you can just mental math it. Your first term, 2 times 1, that's pretty easy, that's pretty easy. And then of course we would need the 100th term, 2 times 100. Yeah, and I of course probably have more work for that than you will. All right, let's punch it in. What's your final sum answer? Can we maybe read that? 10, 100. Good work. Here, let go us. And of course, I don't need all of this little computation to get the first and last term. You can just mental math that, of course. So that's what it means when it says without a graphing calculator. You're not just hitting math 0 and punching it in. Now, the next one says with your graphing calculator. So, I mean, really, no work needed. We're going to hit math 0. Just to show you again, let me quit out of this. So in your math menu, I don't even scroll down, I just hit 0. I just know it's down there. And then it pulls up the sigma for you. Now, you can use any variable you want. It has n on it. I mean, I'm just going to keep it easy on myself and just use the x key, because who cares what variable? 1, right arrow, go up to 50 then. Right arrow, and then just type it in, 40 minus 2x. Hit enter, and there we go. Too easy. It's too easy, Jake.
Why can't we do that all the time, though?
Because we need to know why your calculator is giving you those answers. Where do they come from? You don't want to know the why, Jake? Crushing my spirit.